Okay, we should be recording now. Yeah, there we go. All right, ladies and gentlemen, here's what we're going to do. In this video, we're going to talk about some parts of a circle, areas, arc lengths, and, well, approaching something kind of like this. So here's what we've got. We've got a circle. The center is at O. We've got a radius drawn from OA and another from O to B. It says that the radius is 4 centimeters. That really is a 4, I promise. And that's the information we're given. Now we're also told that the angle right here from BAO is a 60-degree angle. So we're told all those things, and then we're asked to find the minor length of the arc AB, minor arc length AB, the area of the sector, AOB, and the area of this shaded segment, the segment created by the circumference and the segment, the line segment, AB. So let's get to it, right? So first of all, let's start off with the minor arc length. So the arc length is it's a portion of the circumference, and the circumference is 2 pi r, right? So the thing is, the circumference goes from here all the way around. Well, the arc length, the minor one, goes from A to B along the edge. So it has part of the rotation. The full rotation is 360 degrees, right? But we have part of the rotation. So this would be your formula right here for arc length. Now in this case, we have 60 degrees, right? Let's put a little degree there. Times, let's see, it's going to be 2 times pi times 4. So that's 8, right? So that's going to be, this reduces to 1/6 pi times 8. So it's going to be 4 over 3 pi when you're all done reducing, I think, right? So let's double check that. 2 times 4 is 8. Yep, 6 and 36 reduces to 1/6, though no calculator even needed. That's the exact answer of the arc length right there. So this is the formula right here that we're going to use for arc length. Most likely, you won't be given that formula. You're going to have to remember it. So the way you're going to remember it is, remember this, like this is the circumference, 2 pi r. That's all the way around, right? But that's 360 degrees of rotation traveling along the circumference, the edge of the circle. But we're not traveling the entire circle, we're only traveling this angle. So we're doing 60 out of 360. So that's the portion of this right here is the portion of the length around the circle that we have. All right, cool. Let's see. Let's call that one done. Right, there's number 1. Let's talk about number 2. Let's talk about the area of this sector. All right. So now the sector is, well, it's an area, and here's the thing. We're talking about the area of a circle, which is pi r squared. But once again, that would be for the whole circle. We don't have the whole circle. We have 60 degrees out of 360. So this is the formula that you're going to use. It's your angle, theta, right, out of 360 times pi r squared. So this is the portion that you have. This is the portion, right? And this is the area. A sector is a portion of the area. Just like the arc length is a portion of the circumference. All right, so 60 out of 360 once again, right, times pi r squared. So that's going to be, r is 4, right? So actually I already have the formula written right there. So I'm just going to put 4 here. So that's 16. So you have 1/6 times 16 pi. So that's going to be 8 over 3 this time. And so that's going to be 8 over 3 pi, and then centimeters squared. Whereas here earlier we were a little lax with our units, centimeters, so I apologize. So 8 over 3 pi centimeters squared. So that would be the area of the sector right here. Okay, now we're going to find the segment. The whole thing right here. Now there might be a formula, there might not, but even with just what we know, we can figure this out. And these are the kinds of questions that you often see on tests. So, so check this out. Here's what we're going to do. Check this out. I'm going to draw a little picture. I'm going to draw a picture formula. Man, these keep us out of trouble so much. So that's the sector. If I subtracted the area of that triangle right there, this triangle, then what I would have left, let's see here, what I would have left would be that area of that segment. Do you see? So I know what this is. This was, what was it, 8 pi over 3 centimeters squared. Now if I can figure out the area of this triangle and I can subtract those two, then I'm done. All right. How can we figure this out? How can we, let's see. Well, there is a formula for the area of a triangle that uses trigonometry. It's 1/2 sine of A times B times C. So 1/2 sine of A times B times C. Now B times C, B and C, those are the angles, and this is, sorry, the sides and the angles included. So this would be maybe side B, and this could be side C, and that would be angle A. So 1/2 times the sine of 60 degrees times B times C. Now I happen to remember that the sine of 60 degrees is square root of 3 over 2. So what we have right here is 1/2 square root of 3 over 2. Oh, wow. Times B times C. So that's times 4 times 4, which is 16, right? Times 4 times 4, which is 16. So that's going to be 4 root 3 centimeters squared. That would be the area of that. If you reduce all this, right, that makes 4. 4 goes into 16 4 times the square root of 3. 4 root 3. So that would be our final expression right there. That would be exact. Can't simplify it or anything like that. Centimeters squared. So in fact, the way some of these questions are actually worded is it will say, show that the area of the segment is, it might be something like A root 3 plus, I don't know, B pi centimeters squared. And it will ask you, what are the values of A and what are the values of B? Well, so here A would be -4 and B would be 8 over 3, like that. So anyway, hope this has been helpful. Hopefully it's been useful. Man, lots of new information with all these circles and angles, but there we have it. Hope you guys are having a wonderful day, and I'll talk to you soon.